Question 2. Airboats are used for transport across a river. To move the boat forward, air is propelled from the back of the boat by a fan blade. And then you've got the diagram showing you explaining what's happening. An airboat has a fan blade of radius 1.8 meters. This fan can propel air with a maximum speed relative to the boat of 20 meters per second. The density of air is 1.2 kilograms per meter cubed. A. Outline why a force acts on the airboat due to the fan blade. Well, because it's related to force, right? You want to think about Newton's laws. In particular, because it asks about the airboat, the fan blade, and it tells us that the fan propels air, right? The fan propels air. We want to think about the Fab law. The force on object A to object B will be equal to the force of object A to B equals to force of object B to A. So first you want to talk about Fab law, which is also known as Newton's third law. And then you want to link it to the context of what the actual question is asking of you. So in this case, it would be the fan blade. The fan blade the force of the fan blade on the air is the force exerted makes more sense, is equal to the force of the air exerted onto the fan blade. And as you can see in the diagram, because the fan blade is part of the airboat, I don't know if it's, I guess it's not, because the fan blade is on the airboat, right? That causes the boat to move, basically. But because it only asks why a force acts on the airboat due to the fan blade, it's because of the fan blade pushing on the air. And then that's equal, yeah. So explain Newton's third law, just identify that, and then just put it that it's because the force of the fan blade on the air is equal to the force of the air exerted onto the fan blade. And as a result, there's a force acting on the boat. Thus, okay. In a test, in a test, the airboat is tied to the riverbank with a rope normal to the bank. The fan propels the air at its maximum speed. There is no wind. Let me underline that. Results so that a mass of about 200 kilograms of air moves through the fan every second. Show that the tension of the rope is about 5 kilonewtons. So because we know the maximum speed and the mass, well, first we can utilize F equals to ma. Otherwise, yeah. And because we know that the maximum speed, as stated above, is 20 meters per second, we can insert the formula. Which will roughly get you about 84880N, which is close to 5kN. Close to. And that is a 1 mark question. Here there's a slight mistake in the calculation. So we move on to the next page. So the rope is untied and the boat moves away from the bank. The variation with time of the speed of the boat is shown for the motion. C1. Estimate the distance the boat travels to reach its maximum speed. Well, since this graph shows the velocity, speed time graph, and that's arc, you can use the area under the graph. So the area under the graph to find the distance. As a result, we get, or like not we get, let me break it down for a second. So let's see. That's about 10 times 10 divided by 2, because of triangles, I get 50. It's one section. Then can go across. Which would be about 8 or 10. Sorry, this is not very seeable. 10, it's 40, so there's the difference of 30. 30 times 10 equals to 300. 50 plus 300. B. Then we can due to the fact that it's curving, we should, estimate a bit. This is roughly a triangle, so point is about 16.6 times 25 minus 10, so 15 and 40, 25, another 15, 15 times 16.5 minus 10, so times 6.6, and then this last part, let's assume 15 times 2 to the power by 2, which is 15. Then we add, this all together to get roughly an answer. Wait, 16? Wait, no. Not 16, this is, what? No, this is 6. 6 times 15 plus, oh, this one is divided by 2. 6.6 times 15 divided by 2 plus, this is a B, C, D, E. Then 15 times 6.6 plus 15, just 15, which gives roughly 153.5 meters. And in the mark scheme, the accepted distance is between 480 to 560 meters, and this falls in the range. So the method is in finding the distance is correct. Just, it's all about the graph. Now we want to deduce the mass of the airboat. Since, what was the formula again? So to deduce the mass of the airboat, we want to go back and use the graph again, but not the part where it starts to really accelerate, just the start, because how is it? Kind of messes with the rest. So we go from like 0, like the straightest part, so 0 to, yes, let's see, 6, 0 to 6 meters, because as you can see, it's 6, so got the change is 6, so 0 divided by 6, so it's 1. It's the acceleration. the force, we can assume the force from our previous estimate, right? To be from our previous answer, which was, where is it? From either the given, which was, and so we use the force equals mass times acceleration. Again, I hope it's on the page. Maybe I should, let me write this again. Force equals mass times acceleration. Newton's second formula, I think. And we try to find for mass, right? So we've got acceleration as 1, and we can assume F from our previous value in 2b, which we put as 4880. Put that M. So put that 1 equals 2 M, which means the mass is roughly 1880 kg. However, in the mark scheme, it does state the amount of tension from here to have been 409, which I'm not sure how they reached that number, but it should show that it's close to 5,000 newtons. And so you do get marks for carrying over and understanding that this is to do with newtons, the F equals ma formula. So yeah, on to the next question. The fan is rotating 120 revolutions every minute. Calculate the centripetal acceleration of the tip of the fan blade. So since this talks about centripetal acceleration and general circular movement, rotations, right? We want to use the formula of acceleration equals to v squared over r. Yeah. So trying to figure out acceleration, we know. Give me a second. Wait, give me a second. Let me do this again. So we know it's about circles, right? So we've got the radius, which in that it stated it was 1.8 meters. So we've got a radius of 1.8. The fan spins, so this fan spins about this amount of times every second per second. Oops. So with that knowledge, we can use the formula acceleration equals to 4 pi 2r over t. This is the period, which we know is about 60 seconds. Equals to 4 pi squared 0.8 for 60 squared. And that should give us okay, never mind. Sorry, let me redo this again. So, you know that the fan blade has a radius of 1.8. Right. And basically, in order to calculate that, we want to use, let me shift this bit down. Want to use one of these two formulas. Wait, is that the right one? No, this is for V. Oops, that's for V. And the other one is that equals to W squared R, omega squared R. So, in order to find the acceleration, you kind of need to find the linear speed. To find the linear speed, we need to figure out what time period is. So we have the time period, which is technically every minute, so 60 seconds. Wait. So V will equal to 2 pi 1.8 divided by 60. Two pi times 1.8 divided by 60, which is this tiny number. Then we use that to find acceleration. Squared divided by 1.8. That would give us no. Nah, something's definitely wrong. So angular speed is 4 pi radians basically. So that means 4 pi pi 360. Wait, no, 1 was radians again. No, pi, because it's a full sweep. And because of that, square it and r. So 4 pi squared 1.8 . What the heck? Wait, oh, I need this in radians. Give me a second. Make sure if it's about angular speed, change your angle units, please. What the heck? Why is it still the same? Oh, that's why. It's in radians. I forgot how to do radians. Give me another piece. I will return with another piece of paper to clear up my misunderstanding. Okay, new piece of paper. So, in the question, it says there are 120 revolutions every minute. 100 revolutions means like 120 spins every minute, so times 20. So, as stated before, we want to use circular motion, or the ones with the omega would be the simplest. Omega squared, the radius times r, and omega is the angular speed in this instance. Because it's in radians, right? Wait, give me a second. 60 goes 2 times around half. 1/3 80 is that, and a whole is 2. So there's 2, it's 4 pi. That's the logic I forgot about. 4 pi radians. The salt, you do 4 pi squared times 1.8. Make sure your calculator is in radians. What the heck? 4 pi 4 pi squared times 1.8. There we go. Make sure it's on the outside, guys. Make sure it's 4 pi and not 4